All right, let's just dive right into this algebraic adventure. Welcome to today's explainer, where we are going to be cracking open the mystery of hidden numbers. Literally. Today, we're mastering equations by treating them like a giant magical balance scale. So what if you had a magical gadget that could reveal absolutely any hidden number? Imagine reaching into some kind of 4D pocket and pulling out the ultimate tool to solve math puzzles, like, say, easily figuring out what mysterious number when added to 3 gives us 10. Now, obviously we know in our heads that it's 7, right? But how do we represent this problem in a simpler, way faster way without having to write out a massive word puzzle every single time? Well, instead of writing out that whole long sentence, we can express it super simply as a linear equation in one variable. Take our example, x plus 3 equals 10. We just assign a letter, like x, to be our unknown number. And it's called linear simply because the highest power of x is just 1. No squared or cubed numbers here. And this whole setup has 3 main parts. You've got a left-hand side, a right-hand side, and an equality sign sitting right smack in the center. Now, this actually breaks a massive mathematical myth. I mean, so many of us grew up treating the equal sign like a button on a calculator, right? Like, it just means calculate the answer right now. But that's totally not true. The equal sign actually acts like the perfectly balanced fulcrum of a physical scale. It tells us that the left-hand side is in perfect harmony with the right-hand side. So it's an ongoing relationship, not just a one-time action. And because this is a perfectly balanced scale, we have to follow the golden rule. To keep our magical scale from tipping over, whatever you do to the left-hand side, you absolutely must do exactly the same thing to the right-hand side. So if we add, subtract, multiply, or divide by a number on the left, we literally have to do the exact same operation on the right. And you know what? This is the core secret of the inverse operations method. Let's put this into practice and solve a slightly trickier puzzle. Say 2x plus 5 equals 13. Our whole aim here is to isolate that mystery x box all by itself. First step, we eliminate the plus 5 by doing the inverse, or the opposite, which is subtracting 5. But remember the golden rule. We have to subtract 5 from the right side too. That leaves us with 2x equals 8. Next, we gotta eliminate that 2. Since it's multiplied by x, we do the inverse and divide by 2. Divide both sides by 2, and boom, we are left with our answer, x equals 4. But wait, we aren't done until we check the balance. It's absolutely crucial. We take that 4 and substitute it right back into our original magic box. Let's see, 2 times 4 plus 5. Calculate that out, 8 plus 5 equals 13. And what was sitting over there on the right side? 13. Both sides equal 13. Proving our scale is still perfectly level, and for sure, our math is totally correct. So we've completely mastered the magical balance scale today using the inverse operations method. You now know exactly how to treat equations as relationships, not just quick calculations. But here's a question to leave you with. If the inverse method unlocks this puzzle by doing the exact same thing to both sides step by step, what other mathematical mysteries could an even faster tool, like say the transpose method, solve? Keep that balance in mind, and I'll catch you guys in the next explainer.